Hi, for today's lesson, we'll be learning about implicit differentiation in calculus. Implicit differentiation is a technique used to solve for derivatives. It involves differentiating each side of an equation with two variables, usually x and y, with respect to a particular variable as a function of the other. Our first example of this is x squared plus y squared is equal to 49, and we want to find the dy over dx, the derivative of y. So in order to find this, we differentiate with respect to x. Notice that this is our denominator on both sides as given in our definition. And now, a property of derivatives is that we can separate them out. This is just a constant, so the derivative of a constant is 0. So we have a d over dx, x squared, plus d over dx, y squared is equal to 0. This is equal to 2x. We bring this 2 power down and take 2 minus 1. And then this d over dxy squared, however, this is not a variable x, it's a variable y. So what we can do is expand it further. So d over dy times y squared times dy over dx. Notice that these dy's actually cancel and form a d over dx, which would be this. So this works. And now that we have this in terms of a dy, we can differentiate just like x squared. So this would become 2y. The 2 is brought down here, then 2 minus 1 in the exponent. So now that we have this derivative, we have 2x plus 2y times dy over dx. This is what we need to find, is equal to 0. So we bring the x over to this side, and we have 2y times dy over dx is equal to negative 2x. So dy over dx is equal to y prime. Now this prime just means first derivative, so when you see a dy over dx to the 1 power, this means first derivative. So y prime is equal to negative x over y. This was found from simplifying this equation. For our second example, we have x cubed plus 5xy plus y is equal to 9. And we need to find y prime. Dy over dx can also be rewritten as y prime. So now we need to differentiate both sides. So d over dx times x cubed plus 5xy plus y is equal to d over dx times 9. We can split these up into separate derivatives. So d over dx times x cubed plus d over dx times 5xy plus d over dx times y is equal to 0. Now from here we get 3x squared plus, however, this term actually, we need to apply the product rule. So the product rule is for two functions multiplied together to find its derivative. We take the first function times the second function's derivative plus the second function times the first function's derivative. So now using that rule, we can then find this derivative. So we have 3x squared plus 5x times d over dx times y plus y times d over dx times 5x plus dy times y times dy over dx is equal to 0. Reducing this, we get 3x squared plus 5x dy over dx plus 5y plus dy over dx is equal to 0. This was d over dx of y, and this just becomes a dy over dx. Now we need to isolate terms on either side, so we want to eventually solve for dy over dx. We want dy over dx on one side and all the other variables on the other side. So 5x times dy over dx plus dy over dx is equal to negative 3x squared minus 5y. And then simplifying this, we get dy over dx times 5x plus 1 is equal to negative 3x squared minus 5y. This gives us our answer, dy over dx, which can also be written as y prime, is equal to negative 3x squared minus 5y over 5x plus 1. For our third example, we have x cubed over x plus y is equal to y plus 10. We need to find the derivative of y, the first derivative. Now, when looking at this side, we may see that the quotient will be needed because we have a fraction, which we have x and y, numerator and denominator, so we'll use the quotient rule. So quotient rule is for two functions, n is the numerator, d is the denominator. We have the derivative equal to the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over to the denominator squared. So using this rule, we can then evaluate this derivative. So d over dx times x cubed over x plus y is equal to d over dx times y plus 10. Now evaluating this, we get x plus y times d over dx x cubed minus x cubed times d over dx x plus y over x plus y squared is equal to d over dx y plus d over dx 10. So here our nth term was x cubed and our d term is x plus y. The derivative of 10 is just 0 because that is a constant. The derivative of a constant is 0. And d over dx of y is just dy over dx. So now we have x plus y times 3x squared, the derivative of x cubed, minus x cubed times 1 plus dy over dx. So the derivative of x with respect to x is just 1 over x plus y squared is equal to dy over dx. Now we have 3x cubed plus 3x squared y minus x cubed dy over dx over x plus y squared is equal to dy over dx. After bringing this, multiplying each side by x plus y squared, we get 2x cubed plus 3x squared y minus x cubed dy over dx is equal to x plus y squared times dy over dx. Now we still need to bring this dy over here. So doing this, we have 2x cubed plus 3x squared y is equal to dy over dx times x squared plus 2xy plus y squared. So this term here is just this term worked out. So x plus y squared is equal to x squared plus 2xy plus y squared. And then we also have our x cubed dy over dx term brought over from here. So now we have 2x cubed plus 3x squared y is equal to x squared dy over dx plus 2xy dy over dx plus y squared dy over dx plus x cubed dy over dx. Now we can pull a dy over dx out because it is in each of these terms. So doing this, we have 2x cubed plus 3x squared y is equal to dy over dx times x squared plus 2xy plus y squared plus x cubed. And now we can divide by this term, and this will leave us with just our dy over dx. So our dy over dx is equal to y prime, first derivative of y, which is equal to 2x cubed plus 3x squared y over x squared plus 2xy plus y squared plus x cubed. So I hope this helped you in understanding what implicit differentiation is in calculus, and thank you very much for watching.